Hello, everyone. I'm going to work through today with you some stuff. I'm having an amazing amount of technology issues. Um, so I've modified the assignments. So some of you that might have already have done them, they're going to look a little different. You're not going to miss out anything. So if anyone's already done it, there's stuff that's there, but because of technology issues, I've had to trim some things down, and don't worry, we'll get everything in there, and I'll just keep you abreast of any situation as it works out. I'm going to try and schedule some time. I'm going to try and figure out how to get some conferences going on Wednesday, and I will send that information out to you via Remind and or Schoology. So for questions, but for to get started, the assignment for today. Like I said, I've been working on this for hours. It's technology issues. The I've trimmed it down and I've named the assignment you're going to do 3:30 because there was already one and it just had to redo it. 3:30 holes and two vertical asymptotes. Right, so that's what we're going to do: holes and two vertical asymptotes. Don't do the 3:30 week preview. Some of you already did it when it was named 3:30. But now I've called it 3:30 week preview, so that's going to kind of be throughout the week. And or this has been rough, so it might push into next week. We'll see it. So what I'm going to do now, I'm going to try and be brief. So the lesson's starting right now. So what I'm going to do now is I'm going to just kind of look at a function, and I'm not really going to do much writing. I'm just going to show you some stuff, and then we'll flip over the screen and do one, okay? So I'm going to go fast because my other thing will time out on my other screen. So you're going to end up doing rational functions, and the it might look like something like we have here. All right, and we're going to graph this, and the only thing we're going to do any different is we're going to introduce the hole. So there'll be a hole, which in calculus we call a removable discontinuity, but it's basically going to be a cancelable factor. So let's see what that looks like. So how do you know when you cancel a factor? So when you first sit down to do one of these problems, factor it. First sit down. If it factors, factor it. That's the short and simple rule. When you look at a rational function, if it factors, factor it. And this one does. And guess what? There's a removable discontinuity. There's an x minus 5 cancels. So we know for sure the numbers 2 and 5 will not work. Can't plug 2 in there, can't plug 5 in there, because they are discontinuities. They will cause division by 0. But when I'm moving my tablet around too much, sorry. When I cancel that factor out, the function now looks and behaves like this. So maybe I'll go on the other screen again. Sorry for the flicking. When I cancel that factor, that is going to look like 3x over x minus 2. If I only showed you this, there's no way you would remember that 5 was not allowed to be in there. So my suggestion is you write these down when you first factor it. Now, once we've got this, we can use this to graph everything. But my suggestion to you is you go and find this hole first. So basically, why is it not a vertical asymptote? The 2 is the vertical asymptote. Why is it not the vertical asymptote? Because it cancelled. So the one that cancels is a hole, and the one that doesn't cancel, or as many that don't cancel, are vertical asymptotes. Doesn't matter how many there are, if they cancel, they're holes. If they don't, they're vertical asymptotes. So we know we have a vertical asymptote at x is equal to 2, because that's the number that causes division by 0. We know we have a hole when x equals 5. Okay, now without getting too calculusy in here, when we approach 5 from the left and the right, the graph's not going to exist there. So the reason we call it a hole is we know that this graph is going to look something whatever. And when we come to the point 5, there's going to be nothing here. So what we do is we draw a big old hole to exaggerate it. Okay, so that's the hole. So that hole is going to need a y coordinate as well. So how do we figure out what the y coordinate is? Well, we plug it back into this one because this is what it would have been before we cancelled it. That's what it would have been. So you take, to find the hole, you plug the removable discontinuity into the simplified version of the function. So let's see what happens. 3 times 5 over 5 minus 2. So we now know 15 over 3. So we know the hole has a height of 5. So the hole has time 5, height 5. All right, so we're going to go down, and that was what I just showed you there, simplified version. Find that hole, we just did that. Find the asymptotes, and then I'm going to flick past this screen. You're going to do the vertical asymptote and the horizontal asymptote the same way we have done, and when we do the other problem, I'll show it to you. And then you sketch the branches. You find out where they go above or below the asymptote, and you're going to use some guiding points. This is cut right from your explanation on your Alex. All of this blurb says basically find some points. Basically, it says find some points. Try and write that a little better. It's going to say find some points to help you graph it. Well, my suggestion to you is use the points you have and or find the y-intercept. The reason you want to find the y-intercept because what is the x-coordinate of the y-intercept? Well, it's going to be 0. Obviously, a rational function will just have 1. But the point is I was illustrating that the x-coordinate will be 0. That will be very easy to find the y height of the y-intercept. Okay, so you can slow down and refresh and go over that stuff if you needed to look at it again. I'm going to go do the example because it's going to time out here on my other screen. So see if I can get that. All right, so I'm going to do this. Hopefully it didn't time out. Okay, now it looks good. So, all right, what does it tell me? It tells me, all right, I'm going to graph this one, and it's got negative 3x. I'm actually going to write down on paper because I'm going to flick between the screens. Negative 3x minus 12, x squared plus 5x plus 4. Okay, so what we're going to want to do is we're going to want to factor it. We're going to want to cancel. We're going to want to, I can't write on that. We're going to want to factor. We're going to want to cancel. We're going to want to find our vertical asymptotes and our holes and graph it. Okay, so let's go ahead and find some page on. All right, so let's go down here. All right, so what did I say? I said it was negative 3x minus 12 over x squared plus 5x plus 4. Okay, so I'm going to give you a recipe list right here. First thing you do, just factor it. All right, so number 1, let's just call that 1. All right, so let's factor that. So next step, that would be negative 3. Take that, it's going to be an x plus 4. Over here, I've got multiplies to 4, adds to 5, so it's going to be an x plus 1 and an x plus 4. There are my factors. Next thing, write down your discontinuities. So what numbers cause division by 0? So write discontinuities. Whoops, I'm going to run out of room. Discontinuities. So those, our discontinuities are x is not allowed to equal negative 1 or negative 4. Probably should have wrote those in the other order since negative 4, negative 1, left to right. All right, so now the third step would be simplify. Okay, so let's see what happens when we cancel the x plus 4. It looks like negative 3 over x plus 1. Well, that's nice because that's now nice and easy to deal with. So now we can use this to graph. So what do we want? Let's go ahead and find asymptotes. Actually, let's find our hole. No, let's find our hole next. Okay, definitely find our hole. Based on this, it wouldn't really matter if it wasn't computer software, and the way this computer software is working, it's a little. It works out better if you do it this way. So what did we say was not going to be allowed? -4. So I'm going to plug -4 into this. So that would be -4 plus 1. So I'm plugging -4 in here. So -3 over -4 plus 1 is -3 over -3, +1. So the whole is at, when I plug in -4, I get a height of 1. So this is my hole. I'm going to need that. So let me write that down on my piece of paper. Hole is going to be -4, +1. Okay. All right, so I can not flip back to the screen. You might want to write that down too, so where your hole is. We found it. We simplified. We found our hole. Now let's go, once we've found our hole, let's go and find asymptotes, vertical and horizontal. Actually, let's just all asymptotes. So could be slant asymptote. But this equation was a power 1 over a power 2. So one more time, let's just look at the original. Well, let's look at the simplified function, -3 over x plus 1. That's our simplified formula. What is my vertical asymptote? My vertical asymptote happens when x is equal to -1. I kind of knew that from my original function. Basically, one more time, if it cancels, it's a hole. If it doesn't cancel, it's a vertical asymptote. So the opposites of the 4 and the 1, what numbers do I plug in for x that will cause that factor to be 0? So those will be vertical, those will be the holes and the vertical asymptotes. Oops, I did not mean to make myself bigger there. Oh my goodness. Okay, let's make myself really small. I don't know how to do that. I'm going to put myself down in the corner there. I'll put myself over there. All right. All right, so actually I'm going to get rid of myself. All right, so give me some more room. So what did we have? We factored, we wrote our discontinuities, we simplified, we found our hole, we found our vertical asymptote, which is one of our asymptotes. We could find vertical asymptotes, horizontal asymptotes, and we could find that slant asymptote. Remember where you do the synthetic division? But that's not part of today's lesson. We'll refresh that later, and you can ask that in questions. Vertical asymptote x equals 1. Horizontal asymptote means you divide by your biggest power. So -3 over x, x over x, and 1 over x. What happens at really big numbers? That becomes 0. This becomes 1. That becomes 0. So what is 0 over 1? Oh, it's 0. So your horizontal asymptote is y equals 0. This was all those lessons the week before we left, but I'm just for now just roughly reminding you, divide by the biggest power, imagine big numbers of x, and then what would the number practically be? Cookies and friends. So we've got our vertical asymptote, our horizontal asymptote. We don't have a slant asymptote because the top is not heavier by 1. All right, so in this lesson you won't have slant asymptotes. So now something else to think about is -3. What was it? -3 over x plus 1. I like to always go in and find my y-intercept because it's always going to be a nice guiding point. this will not have, first of all, this won't have any x-intercepts because the numerator will never be 0. So that function will, this fraction will never, that's y height, this is the function. This number, doesn't matter what numbers you plug in for x, this fraction will never be 0 because the numerator is -3. It doesn't really matter what you plug in for x, the entire fraction will not be 0. So there is no x-intercept. The y-intercept, however, is when you plug in 0. So when I plug in 0, I have -3 over 1. So -3 over 1, the y-intercept is -3. All right, so now let's take all of that. I'm going to... what was next? I'm looking at something here. That's my y-intercept. What did I say x was? X was -1. What did I say that was for? Oh, that was the vertical asymptote. Okay, it was on my paper. And so now let's go over to and graph all of this. So, all right. So let's go in and plot our points. So first of all, I suggest plotting your points. So my hole, so how I got to my hole was I chose this little line right here, right there. So I'm going to put my hole, and I said my hole was at -4, 1. So I'm going to plot my hole right there. I'm going to plot a point, so I'm going to plot my y-intercept at 0, -3. Okay, that looks good. I'm going to plot my vertical asymptote at x equals -1. And I'm going to plot my horizontal asymptote at, wasn't it, y equals 0? Because it was 3 over x minus 1, or x plus 1. So then I'm going to plot these after I hit, whoops, undo that. Oh, it undid everything. Okay. So I'm going to hit this key right here, gets my vertical asymptote, x equals -1. Sorry about that. I cleared it off. Y horizontal asymptote of 0. Then it does these branches. The reason I had you graph the hole was because now you've either got to choose on the left of your vertical asymptote, you're either above the horizontal or below. So we know we're above because the hole's above. The functions are going to behave exactly the same except at that point. So they go right up to that point, which is the limit, and then move away. Now, on the other side, we know our y-intercept was at 0, -3. And I did. I get my point right there. That's perfect. So I just put my branch on 0, -3. I didn't even have to. Okay, I'm just figuring that out for you. I didn't have to plot my point. So I put my piece at 0, -3. And then I'm done. I can just turn that in. So that's it. You can rewind and much as you need. I'm trying to keep this up for the people that have a lot to do today. I'm going to look at this other guy. Now, we have to pick the graph of the function that matches. So if I look at f, let's look at f first. F is a power 2 over a power 2, which means it's got a horizontal asymptote of 2, because when I divide every term by x squared, it will leave me 2 over 1. So it has a horizontal asymptote of 2. So that is definitely, that's A or B, definitely not C, definitely not D. So it's E. So you're down to A, B, and E. That's horizontal asymptote. Now let's see. We factor. I'm gonna find the x-intercept. So I'm gonna set 2x squared plus 2 equal to 0. I'm setting the numerator equal to 0. So let's see. Maybe I can go to the page right here. So I'm going to set the numerator equal to 0 gives x-intercept. Denominator equal to 0 is either a whole or vertical asymptote. So we set the 2x squared plus 2, which is the numerator, equal to 0. So let's see. That subtract 2 divided by 2. So x squared is equal to subtract 2 divided by 2. X is down now. That's going to have, because that's the square root of -1. So there will not be an x-intercept. So when we go look at that, there will be an x-intercept because you can't take the square root of -1. So there's no x-intercept in F, and it's got a horizontal asymptote of 2. So let's see. So A does not have an x-intercept, and it has B. B has an x-intercept, so it cannot be B. Which other one did we say had a horizontal asymptote? And E has an x-intercept, so it can't be E. So by process of elimination, it has to be graph A. All right. Now let's look at graph H. So it is a power 1 over a power 2. So power 1 over a power 2. So it has a horizontal asymptote of 0 because it's bottom heavy. It's stronger heavy on the bottom. So it's going to have a y equals 0 horizontal asymptote. And there are only 2 of those, D and F. We already chose. So D and F, so it can only be D or F because those are the only 2 with a horizontal asymptote of 0. Because divide everything by x squared, the deal. So now let's see what the vertical asymptotes are. So I'm going to factor x squared. Actually, I can just do it. X squared minus 2x. Oh my goodness, what was it? X squared minus 2x minus 8. X squared minus 2x minus 8. Factor that's going to become what multiplies to 8 and adds to -2. So it'll be x plus 2 and x minus 4. X squared minus 4x plus, yep, that's right. So x plus 2. So the vertical asymptotes are going to be at -2 and +4. So let's go, if it doesn't cancel. Yeah, and the numerator is just a power 1 x. So we said they were at -2 and +4. D or F. Okay. And we're going to have to find the x-intercept. So when you plug in 0, you will get the x-intercept because we need to set 3x equal to 0. So when does the x-intercept happen? When the numerator is 0. When you set 3x equal to 0, the answer is 0. So the one that has F has the horizontal asymptote of 0. It has the x-intercept of 0. And it has the vertical asymptotes -2 and 4. Okay. And then we just check that. We're good. Okay. So that's the lesson for now. And I will keep you updated in the week. And we'll keep you updated in the week. I might just extend some of these lessons. We'll see. Just get on them and do those problems and be ready to ask questions on Wednesday. And I'll send out some more information about when that will happen. Okay, thanks a lot. Have a good day.